Okay, so we've all been there, right? You get a paper cut, you scrape your knee, and what's the first thing you do? You reach for a bandage. It's almost muscle memory. But what if I told you that simple little patch is based on technology that's over a century old? It's time for a serious upgrade. So let's dive into the incredible future of healing.
No, really, think about it for a second. We live in a world of self-driving cars and artificial intelligence, yet our basic approach to covering a wound hasn't really changed. And look, for a tiny scrape, that's totally fine. But when it comes to the major medical challenges we face today, that old tech is completely and dangerously outmatched.
Because for so many people, we're talking about folks with diabetes or severe burns or infections from superbugs, a wound isn't just some minor thing, it can be a life-threatening problem. A standard dressing just can't keep up with drug-resistant bacteria, and it definitely can't create the perfect environment needed for the body to rebuild complex tissue. This is exactly why scientists are now looking for solutions on a scale so small you can't even imagine it.
But before we can build a better bandage, we first have to appreciate the amazing healing program our own bodies are running 24/7. It's this beautiful four-step biological dance.
First up is hemostasis. That's just a fancy word for stop the bleeding. Your body creates a clot to plug the hole. Simple enough. Next is inflammation. This is where the first responders, your immune cells, rush in to clean up the mess and fight off any nasty germs. Then we have proliferation. This is the rebuilding phase. Your body starts laying down the foundation for new tissue and growing new blood vessels. And finally, maturation, where everything gets remodeled and strengthened, which, is what eventually forms a scar.
And this image right here shows that entire process perfectly. You can see it all happening. The clot forming in that first hemostasis stage, then the immune cells showing up to do their job during inflammation, then you see that new tissue starting to form in the proliferation phase, and finally, it all gets remodeled into stronger tissue. It's a really incredible system, but sometimes when it gets overwhelmed, it needs a little help.
And that is where nanotechnology enters the picture. We're talking about scientists engineering materials at the molecular level, stuff that's thousands of times smaller than a single human hair, all designed to give our body's natural healing process a massive boost.
So here's a cool way to think about it. What if we could send in a team of microscopic superheroes right into the wound, each one with its own unique power, all working together to help your body heal better and faster than ever before? Well, that's pretty much exactly what nanomaterials are doing for wound care.
All right, so let's meet this team of nanoheroes. Researchers have identified a few key players, and each one has a very specific and very powerful job to do.
First on our team, we've got the metallic nanoparticles, or MNPs. These guys are the assassins. Their one and only mission is to hunt down and completely eliminate any harmful bacteria that could infect a wound and grind the healing process to a halt.
So how do they actually do it? Well, take silver nanoparticles, for example. They're one of the most well-known. They don't just attack in one way. They launch this all-out assault. They physically punch holes in the bacteria's cell walls, they create these destructive molecules that cause chaos inside, and they even mess with the bacteria's DNA. It's such a comprehensive attack that it's incredibly hard for bacteria to fight back.
And just like any good superhero team, they have specialists. Silver is the ultimate bacteria killer. Gold nanoparticles, on the other hand, are kind of like the diplomats. Their superpower is calming down inflammation, which soothes the wound and helps new tissue grow. And then you have copper. Copper is the master builder, encouraging the growth of new blood vessels, which is absolutely vital for bringing in the supplies needed to rebuild.
Next up, we have the metal oxide nanoparticles. Think of these as the regulators, or maybe the battlefield commanders. Their job is to manage the whole process, making sure that inflammation does its job but doesn't get out of control, all while encouraging new tissue to grow.
Then we get to a really cool one, MXenes. These are the scaffolds. Imagine trying to build a new wall without a frame. It wouldn't work, right? Well, MXenes are these unbelievably thin 2D sheets that create a perfect microscopic framework for new cells to grab onto and start rebuilding the damaged skin.
And how do they make these things? It's pretty wild. Scientists take a special crystal and essentially peel it apart, layer by atomic layer. What's left are these flexible, conductive sheets that are also biocompatible, which means our own body's cells love to grow on them.
And because of these unique properties, you can do some really futuristic stuff with them. Get this. This image shows a microneedle patch made from MXenes. You can load it with medicine, and because MXenes react to light, you can just shine a little near-infrared light on the patch to release that medicine exactly when you need it. How cool is that?
And speaking of delivering medicine, that brings us to our final hero, Metal Organic Frameworks, or MOFs. These are the team's high-tech delivery trucks. MOFs are basically microscopic cages with tons of little pores. You can pack these cages full of medicine, like antibiotics or growth factors, and design them to release it slowly over time or only in response to a specific signal.
And this is where the magic really happens. The real power here isn't just one of these heroes. It's combining the whole team into one smart bandage. This diagram shows how you can have a single patch that does it all. It's fighting bacteria, it's calming inflammation, and it's helping grow new blood vessels to rebuild tissue. You see, this is so much more than just covering a wound. This is actively managing and orchestrating the entire healing process from start to finish.
Now, as incredible as all this sounds, we have to be realistic. We're not quite at the point of finding these on the shelf at your local pharmacy. This technology is full of amazing possibilities, but there are also some pretty big hurdles that scientists are working hard to clear.
So let's break it down. On the one hand, the pros are huge. You've got this insane power to kill all sorts of bacteria. You can actively promote regeneration, and you can create these smart treatments. But on the other hand, there are real questions we need to answer. At high doses, some nanoparticles can actually be toxic to our own cells. They can also clump together, which makes them less effective. And frankly, we still need more research on what they do to our bodies and the environment in the long run.
But the ultimate goal, the vision here, is crystal clear and so exciting. The point isn't just to make a fancier piece of gauze. The goal is to create a truly smart dressing, one that can actually sense what's happening in the wound. Is there an infection? Is inflammation too high? And then respond automatically, releasing the exact right medicine at the exact right time.
So, let's go back to that simple bandage we started with. We began with this passive little cover, but the future of healing is anything but passive. It's active, it's intelligent, and it's happening on a microscopic scale. So I'll just leave you with this final thought. What if the next time you get a cut, your bandage doesn't just cover it up, but it works with your body, rebuilding your skin atom by atom? That is the incredible future that this team of nanoheroes is making possible.